Good evening, students. I'll start with the class. Okay. So first, I'll just give you all the pattern, means the marks and all for physics. I'm directly starting with the portion today. I'll just give you the physics paper pattern of physics portion. For the entire year, this is a. So you will have 4 tests overall in the whole year. So the first test will be of 20 marks. Second test also 20 marks. Then in between they'll give you one assignment that will be of 10 marks. Then there will be a third test, again 20 marks. Fourth test, 20 marks, and one project will be. So total will be 100 marks for your final essay. Same way you will have practicals also in physics. Okay, practicals anyways we don't cover. Practicals will be covered in your college. Okay, that will be basic like experiments and all. Based on your theory only, there will be some certain practical exams or experiments which you have to do. So that is nothing related to this theory. Still, if you want, I'll give you the pattern for the practical exam. Same way, you'll have first, this is for practical. We'll have first test for 20 marks. Second test also for 20 marks. Then you'll have your first practical exam. Dates and all, then they will tell later, okay? When exactly it will happen. Once they go on completing the portion, they'll keep the exam. First practical exam will be of 10 marks. Then third test, fourth test, and then second practical exam. This is exam. This is a normal test. So whether they'll hold it online, offline, that they have still not mentioned. So as of now, you have to consider it to be online only. So again, that will be 100. So this is about the theory part, and this will be of the practical. Any queries in this, you can ask. Huh? So now, first test, which all chapters will be there as per the test, that distribution I will give. If you want, you can copy down or take a screenshot and keep. Now, which all chapters will be there for the first test? you all must be having normal textbooks. Okay, those who don't have a normal textbook in physics and all, online, no, you'll have an app called as NCRT books. Okay, you need help, you can ask me also later on that app. I'll show you the symbol, how it looks like. All the books are available online, means all the textbook, all the chapters. If you don't have a physical book with you, you can always refer. There's an app directly which you'll get it, all the textbooks in there. If anybody wants that app, you can just text me, then later on I'll tell you which one. The chapters, if you have seen on your textbook, there'll be first chapter, that is physical world, but now it has been deleted. The entire chapter is not there for you. Units and measurements. That chapter you have. So we'll be starting from this chapter today. That will be for 5 marks. Third one. So this chapter is not there, okay? So that's why I put there. Motion in a straight line. That is for 6 marks. And then motion in a plane. For 9 marks. So total 20 marks. So these 3 chapters you will have for the first test. Second test. Laws of motion. Work, energy and power. This is 6. Then gravitation. Then mechanical properties. Of solid. This for 3 marks. Total is again 20. So these chapters will be there for your second test. Then third test. Mechanical properties of fluids. Second, system of particles and rotational motion. Thermal properties of matter. As per thermodynamics. Again, 20 marks. Then the last test. Here and there it is. First one is kinetic theory. Then oscillation. The third one is waves. 5 marks, 7 marks, 8 marks. Total 20. So this is chapter wise and marks distribution for your all 4 tests. Now physics, when if you see, now you'll see a vast difference from your 10th standard now in 11th. Okay, the moment you have chosen a science stream means you have to now sacrifice all your wasting of time, all time pass gone now, because there'll be a lot of portion, like maths will be a separate entire subject with so many chapters. Same with physics, chemistry. And physics, normally students find it little bit difficult in 11th. 12th standard physics is comparatively very easy compared to 11th. But what same like how you can drop math if you find difficult in 11th, you will say, okay, you all always have that option of dropping math in 12th. But physics is a compulsory subject. You cannot drop it. So at any cost, you have to study and clear it. Okay, so we'll start with the first chapter, units and measurements. Which is for 5 marks. Okay. Before starting with the actual portion, now just I'll quickly tell you the difference. We'll be hearing this word called as mass. Okay. So I want to tell you what is the difference between mass and weight. We always have this confusion. Whenever somebody asks you what is your weight, we normally tend to say 30 kgs, 40 kgs or whatever, but which is actually wrong. Okay. I'll explain to you. First, if you want, I'll give you the definition. Right? This is not to by heart or study for your exam point of view. This is only for your understanding, okay? That there's something called as mass is different and weight is different. So mass is nothing but the mass of any object is the amount of matter that is present inside in an object, in that object, okay? And weight is nothing but, I'll explain to you what exactly it means. Even if you don't write the definition, it's okay, but that's not there in your portion as such. Weight of any object is the force exerted on the object due to gravity. What basically means this? Suppose if you have a person who is saying this 70 kg. So whenever I'm saying this is 70 kg, that is not a weight. That is something called as mass. Okay. So what I'll do on Earth, I will just refer so that you understand the later difference. Suppose now this person is standing on this Earth. So what I will say is mass is 70 kg. So whenever he's standing on the weighing machine and is looking, so that is what you're checking is mass. If you want to know the weight, weight is nothing but mass into gravity. Gravity means on Earth, why we are standing on Earth, why is it possible for us to stand on the Earth is because we are means we have been taken care by the gravity. Okay, so that is why we are able to stand. So it's nothing but like the force which is making us to stand. So that gravity force is a fixed value, you know that is 9.8. So when you want to actually calculate the weight of the person, he will be nothing but 70 into 9.8. So approximately if you calculate, you'll get around 686, and that is not kgs. Weight is always measured in terms of Newton. N. Okay, so basically what I want to tell you is whenever you are asked what is your weight, it is not exactly weight. Suppose if you are weighing 40 kgs, it is your mass, not your weight. Only when you multiply it by 9.8, that will be your actual weight, and that will be given in terms of Newton. So if you are weighing 40 kgs, so that is what you are saying is that is actually your mass. And weight would be if you multiply it by 9.8. 40 into 9.8 newtons will be your actual weight. Okay, this is on Earth. Now, suppose if you are in space. In space, what? Same, that the same person is going on space, suppose. His mass anyways will remain same because he will not shrink. He will not become very small in space. Okay, whatever is there inside his body will be there only. So that mass will remain as 70 kg. But is there gravity in space? gravity is zero. You know that. There's no gravity in space. So what would be of this fellow's weight in space? Zero. Because gravity is zero in space. So mass is what remains same on Earth as well as in space. So whenever you say weight, that is actually multiplied by your gravity. So whenever I'll be referring in this chapter mass, it's always like whenever I say 1 kg sugar, so that I'll be talking about mass, not the weight. So remember that. So 1 kg sugar, this kg will be mass. So just this, okay. So anyone having doubt can ask if you have not understood the difference between mass and weight. So everywhere you'll come across this word now, mass. After that, what you need to know is what is a physical quantity. Again, you'll come across this word. Physical quantity is nothing but a quantity which can be measured. Okay, you can actually count it or measure it. Example, length. We always measure the length. Can anyone tell me in what how we can measure in terms of like what will be the units? Various ways you can measure length in terms of centimeter and yes, centimeter, then
Kilometers,
yes, kilometers and meters. This is common. Anything else?
millimeter,
What?
millimeter,
Yeah, millimeter. Okay, these are the common ones which we normally use. Then anything else I can think of?
Inches.
Yes, inches also there. Inches is, if you don't know, this is around 2.54 centimeter. If you have a scale, no? If you count up till 2.5 centimeters approximately, like 2 and then between 3, so that will become 1 inch. 1 inch, and then many will be inches. So approximately 2.5 centimeters is 1 inch. Then you can also measure in terms of
feet,
yes, feet. Or one is called as a foot. Okay. If you want to know, just for your information, you don't have to remember these values in exams. Huh? I'm just telling you for your information. 1 foot would be 30.48 centimeter. So normally height of a person we measure in terms of feet. So 1 is called as foot. So when it goes like 5 foot, we don't say 5 foot. This is wrong. Okay. For plural, we normally say feet. So foot and feet is the same thing, but only one is called as foot and many will be called as feet. You can measure in terms of feet also. So this is how you can measure length. There'll be more, okay, like kilometers and decameters and all that. I'm just giving you some examples. Then second one, suppose we have mass. Mass would be same, similar this just now which you have studied, which we have normally thinking as our weight is 1 kg. So now this concept is gone of weight. So that is mass now. That will be milligrams, grams, then kilograms, and kgs. Then tons also you can measure in terms of. And if you must have heard, pounds also. From foreign system, they'll measure the baby weight and all in terms of pounds. Pounds, if you want to know, it's 1 pound, just for information, 453.59 grams, approximately half kg, like, is 1 pound. 500 grams is normally half kg, no? So close to half kg is 1 pound. So like this, you can measure mass in various forms. So that's why it belongs to a physical quantity. So length is a physical quantity, mass is a physical quantity. Same way, you'll have time also. Time also is a physical quantity. You can measure in terms of seconds, milliseconds, minutes, hours, days, and so on. So even time is a physical quantity. One more last example I'll give. Temperature. Does anybody know which all ways you can measure temperature?
Degree Celsius.
Yes, one is degree Celsius, called as Celsius. Then,
Kelvin.
yes, Fahrenheit.
Kelvin.
Kelvins.
Yes, Kelvin is also there. Okay, so these are various ways. Suppose if you want to know the relation, just fire. Normally, we usually prefer this degree Celsius, but in terms of Fahrenheit, the temperature, we get fever and all, we normally like, where it is gone to 100 and all, we say above 100 my fever went. So don't say it is 100 degrees Celsius. If you say degree Celsius, you would be boiling and melting also. So that is normally in terms of Fahrenheit which we take. So Fahrenheit, so Celsius to Kelvin is normally whatever is your this, like 10 degree or whatever x degree, you have to add 273 to it. Suppose 10 degree, I have, if you add 10, you get 283 kelvins. Right. Then want to convert in terms of Fahrenheit. Suppose if you have that unknown number, degree Celsius, you have to multiply it by 9/5 first, and then add 32. This will be in terms of Fahrenheit. Okay, so these are the various ways which you can calculate temperature. So even temperature can be measured. So that is a physical quantity. So anything which can be measured, okay, in terms of certain unit, that is called as a physical quantity. Now, why there's a need of measurement? Need of measurement. Obviously, measurements play a very important role in our life. You can just imagine, like, if the word, this all these centimeters and all did not exist. Normal, if you want to relate the terms, you would say hot, cold, Okay, you would say short, and you will say tall, less, more. These would be normal terms in your day-to-day life. Now you want to go on a shop and then you tell, I want little rice. So that person is not able, like not defined, no? Cannot just go and say, I want very less rice or so much of rice. Exact quantity is required. Okay, so exact measurement. So how much hot, how much cold, how short is that person, how tall is that person? If normal these units never existed, life would have been so difficult. So when I ask you the time, so whenever you say now it is 5 this. So if I did not know what this means, then whether this means minutes, it would be useless. This 5.30 would be just a number. So that is what. So measurement, accurate measurements play a very important role in our life. Otherwise, your car or bike would never have speed. It would just run and run. So you can imagine the life without measurements. So this is very important. So that's why we always have some standard things to measure. So that is always called as a unit of measurement. And that's how we are approaching to the chapter now. So what is a unit? Mostly definitions from this chapter will not be asked, okay? Like define this, define that. Mostly this is problem based chapter. So problems will be asked, which I will be solving in the next class. So this is a standard term. Used for measurement. Whenever you measure any physical quantity, just now which I told, examples like length, mass, time and all, it's always measured like one. Unit means also called as one. Like a second meaning to it. Unit means one. Whenever I say mass of object, is 1 kg. So this means this is 1 unit. So this is 1 kg. Now if I say mass of an object is 10 kgs. So what exactly it means is nothing but 10 times 1 kg. So I'm trying to relate my mass and unit. So this is your unit. This is your mass. The unit means always 1 should be there. It's like 10 units now. 10 into 1 unit will give me 10 units that way. So like when I say 100 kgs, it means 100 units. So basic, who is the reference? 1 unit. So this is like starting base, 1 unit. So it's a standard term used for measurement. Rest all will be like multiplied by 1 unit. So when you say 15 kgs, it would be 15 into 1. That is. This is basic definition of unit. Now this unit should be universally accepted. This is very should be universally accepted. It should be common to the entire world. Okay, everyone should know about it. Now imagine you sit in the house and you just take one small bowl and you put rice in that, and you know that every time you mom cooks or whatever, she uses that bowl for reference, and that is like for her reference. Only she knows about it. Now she cannot say, ah, this is my standard unit, because it should be universally accepted. That will belong only to your house. Like if you're taking syrup, whenever you fall sick, you will take one good day syrup. Now you cannot say this one good is my standard universal unit. Okay, so that is only for you. So you can say it as a unit only when the entire world knows about it. So whenever I say 1 meter, every person will know its length. So that way it should be important that unit should be universally accepted. So that's why we'll have some standard, forms of units. There'll be some fixed things which we have to follow. So that is called as system of units. Which it's like rules, certain rules which the whole world has to follow, or they should know about it. So before starting with the types of systems, I'll just tell you what are fundamental units and what are derived units. Fundamental units are the simplest form which cannot be again divided into more parts, like the basic ones, also called as basic, the start foundation of that whatever you'll be building up. The fundamental units are the foundations, like 3 of them are there. The simplest or the basic form. In terms of definition, they cannot be derived from one another. And cannot be simplified. So the 3 of them are the 3 examples, which are these are the ones: length, mass, and time. So these are your fundamental units, the basic ones. Length cannot be derived from anything else. So length has to be length only. Mass has to be mass. Time has to be time only. Now I'll tell you, now you'll understand what exactly it means after I tell you what derived unit means. This is the first one. Second. Derived means which can be expressed using this, we are forming this. It can be expressed in terms of fundamental units. Like how you have the basic colors, no? Red, blue, okay? Your primary colors also, red, yellow, and all. Now there will be your fundamental colors, and then after mixing those colors, you can make violet color, okay? and then other color combinations you can make. So you'll have like 3 main colors, and then you can combine those colors and get complicated colors. So it's like that. So these 3 are your basic colors, and then you can mix up, and then you can get complicated units. They are called as derived units because they are derived from this basic one. So I'll give you an example. Area. Suppose I want to calculate area of a rectangle. Basically, I want to this is also a physical quantity. Area can be measured. Anything that can be measured, I told you, is a physical quantity. So now, area, if I want to measure, I will need its length, I will need its breadth. So area formula we already know, length into breadth. So length will be considered, we are measuring in terms of meters now. Length will be measured in terms of meters. Obviously, if this is in terms of meters, this fellow also we have to measure in terms of meters. Like this is 10 meters, then this is suppose 5 meters, like that. So this is also meter. So meter into meter, you know that is meter square. You have studied in 10th standard also. Area unit is called meter square. Length is always, distance is always in terms of meters. And area is always in terms of meter square. So what was the basic one? Meter. And from length, we got meter square. After multiplying length into length or length into breadth, distance into distance, we got meter square. So this is called derived unit. Same way, if you had volume, you would have length into breadth into height. Then you would have m into m into m, which would be meter cube. So who was the simplest base? Meter was the simplest base. And then who was the derived one? Volume is a, so area, volume are derived units. These are examples. So these you can write. If you don't understand something, you can always ask. So this is the difference between fundamental and derived. Fundamental is simple one, and then when you multiply, when you divide and do something and then get a different unit, they are called as derived unit. Same like speed also. Speed also will be derived unit. Why? Speed, you know that is distance upon time. So you will get what is the this meter, and if you want, you can write time in terms of seconds. So you got a different unit. So speed would be also a derived unit. So these are fixed. Length, mass, and time. In case you all don't get time also to write or something and I'm erasing and all, please let me know that you have not finished, that you need to write. Now, the system of units, there are 3 types basically. The main 3 system of units. The 3 systems which we should know. We may not write the number, you can just write. First one is CGS system. From where you will get it? Basically, which all quantities are the basic ones? Mass, length, and time I do. This you have to keep in your head, all these three. You cannot forget these three basic fundamental units: mass, length, time. Now, this C means for centimeter. So this length is done. G will be for mass, that is grams, and S means time, that is second. So centimeter, gram, and second. This is one way you can write the unit. So this is for length, this is for mass, and this is for time. The next one is FPS system. Whichever first one I'm using for length. Looking at this F, can anyone tell me length, which unit it can be? F means
Foot.
foot, yes. So this will be foot. Then P for mass,
Pounds.
yes, pound. And then second. So this is always, first one is always for length, second is always for mass, this is for time. Then the third one is MKS. So this will be, M will be for meters, kilogram, just write it as one unit only. Everywhere just remove that S, because if you want to refer it as one, we'll keep it singular only. Meter, kilogram, and second. Everywhere let it be singular, okay? Don't add S to it. Foot, pound, second. Centimeter, gram, second. Meter, kilogram, second. So these are the three this type of systems. So now this system can be followed. You have an option, either you can follow this, or you can follow this, or you can follow this. Certain countries will follow this system. Certain countries may follow this one. Although they know all three, but they can keep this common. All the scientists or whatever is going on in their country, they will follow this system. Some of them may use this. But then when it comes to the whole world, there should not be any confusion, like which country is following this. Like especially helps in terms of this experiments when you're doing, in terms of research. Okay, we have to keep one standard value, because everyone cannot sit and then keep converting them. Like one scientist has done some invention there. Now this other person may not be aware of this system. He must be knowing this. I cannot sit and try to convert and waste time, because there'll be big theories and all. In this case, we normally keep a standard for the entire universe. They are called as SI system, international system. So this is universally accepted and used all over. So I'll give you a list of them. So the whole system is based on 7 basic units and the 2 supplementary units. So you have 7 basic units and 2 supplementary units. Supplementary means just add on to it. So this you should be knowing, okay? This is first one. So this is the basic physical quantity. Like how we have length, mass, time, no? Like that there will be more basic quantities also. Those also I'll give now. This is the basic unit. This is the symbol for it. So total 9 you will need, okay? The first one is length. We know that the basic quantity. So universal entire this standard unit will be measuring in terms of meters, not kilometers, centimeters. Huh? The world standard unit is meters. And the symbol is m, small m, okay? Same way, second basic physical quantity is mass. So the entire world will follow mass in terms of kilogram. That is kg. Symbol is kg. Third one is time. Time is given in terms of second. Yes. Capital S. And fourth one is temperature. Temperature, normally we use degree Celsius, but standard, the word is Kelvin. And denoted by symbol K. Fifth one is electric current. Electric current is always measured in something called as amperes. Ampere. Like how we have voltage, no? When you go to buy a bulb, whatever, you'll say 60 volts, watts. That is for power, watts, you know. Power will be having watts. Then voltage will be having volts. That way, even current has a unit to measure how much current flows in a house. So that would be like 1 ampere, 2 amperes. You have to tell in terms of ampere. So the unit for electric current is ampere. Sixth one, luminous intensity means brightness. How you increase the brightness on your phone and decreases. So increasing. So in terms of luminous means whatever glows. Okay, whatever gives out light is called as luminous intensity. how much intense it is, whether it is very bright, very dull. That is defined in terms of candela. Symbol is CD. And seventh one, quantity of matter. This all will study in chemistry. You will know that every substance, every ion is made out of atoms and molecules. Okay, so every substance will have something packed inside it. So the amount of whatever atoms are present inside it will be measured in terms of mole. You'll study this term in chemistry. Symbol is MOL. Even liquid, anything that is made out of atoms, molecules, can measure the quantity of matter inside that substance in terms of mole. Eighth one, plane angle. In terms of radian. Whenever it will come across, no, this something in terms of pi, we'll have to express the angle. Especially in mathematics, you use this entire 11, 12 will be used, come across something called as radian. Okay, later in whenever needed, I will explain how to convert degrees in terms. Normally till now we used to use angle in terms of degrees, 90 degrees, 60 degrees and all. But the standard one is now in terms of radians. Will not be saying degrees. Ninth one is solid angle. So what is the difference between plane and solid angle? Plane means what you draw on a paper, two-dimensional. Two-dimensional means your x and the y axis, which you draw on your paper. Solid angle will be three-dimensional. Means what? If you take a cake and cut it into 6 equal parts, okay, what that solid angle will make of the cake piece? How much angle? So that is called as a solid angle when it is in terms of three dimensions. And this plane angle means normal while drawing just two lines on a paper. So this is 2D, this would be 3D, three dimensions. So this is measured in terms of steradian. So these are your standard international units, which you should be knowing. Definitions not needed. Is there in your textbook also? You can just go through it if you want, but you don't have to by heart them. Any doubts in this? Not understood these terms? You can ask. Current you can know. Luminous I told you, the brightness. Quantity means how much atoms or molecules are present inside the substance. Plane angle will be normal paper, and solid angle will be three-dimensional. I give you the example of a cake. If you cut the cake, how much angle it will make, if you want to measure, then it would look like a solid angle. Or even a earth sphere, if you cut the sphere, try to cut the sphere in terms of many angles. The solid, whatever you're cutting, will be solid angle. Next is directly dimensions of physical quantity. These are very, very important because it's the base for many problems will be solved on this. Okay, you have to understand this concept. So the dimensions of physical quantity. So these are the powers. Just give the definition and then explain. Mental quantities must be raised to represent that quantity completely. So the three basic quantities which we'll be using is mass, length, time. So we'll be using like the square bracket. M will be for mass, L will be for length, T will be for time. And you will have some powers X, Y, and Z. This everyone will have some powers. So what is trying to say? The dimension are what? The powers which are raised to the fundamental quantities. Which are your fundamental means the basic quantities, mass, length, and time. Okay, to represent a quantity completely. The quantity means this could be various examples like area, speed. So looking at this, we will be able to understand what I'm trying to say, whether it is area, speed, and all. Now you might not be able to understand what it means, but once we start solving and you come back and read the same thing again, it will make sense. Okay, so as of now, you just write. Basically what you should know is you have to follow this only: mass, length, time. This is a fixed standard thing. We will start the table. This will be of serial number, total 1, 2, 3, 4, 5. So this will start with the serial number. Then will be a physical quantity. Next column will be formula column. This you can keep little small, okay? Physical quantity. Just the names you have to write. This dimension you keep big. Dimensional formula. And then last is small one, you can keep SI unit. Just to write the unit. That is column be little big. That last column is SI unit, okay? So the first one, let's start with the basic ones itself. First, the length. Length is always measured in terms of distance. So we normally write which letter we write? L, no? For length, we use L. Now, how to write the powers? This you have to keep fixed. M, L, T. I told you this is fixed like this. Whenever you have length, whenever you're measuring length, okay, with a scale, will a mass, will weight come into picture? No, definitely this is the basic one. So whenever you're measuring in terms of centimeters, meters, no matter what, you're putting a tape and you're measuring, your mass, weight, all this will never matter. So mass is not bothering you. This same way time will not affect. Okay, you're just basically putting a tape and calculating your length. So only length is there in this. There is no mass and time. So what is going to happen? Only length is present. So that's why I'll put it as one power. And there's no mass, no time. So I'll put 0 for it. What is present for length? Only length one I have to put 1. The remaining mass and time I have to put 0. What is the standard unit for length? We have already studied from the table, that is m. Out of the 9 of them, in that first one only I had given. Length is m. Small m it is, not visible, just yeah. The second one is mass. Mass formula will be normal m. Now, again, we have to put same thing, mlt. Now, can anyone tell me which will get the power? Which letter?
M.
S. Yes. M will get your power now, and rest length and time will be 0. What is the standard unit for mass? Kg. For this, I told you those 9 you have to just by heart. You have to remember mass. You know that from that table which I have given before one. Automatically, you know mass is nothing but kg. Then the third one, time. So time will be t. Again, put mlt. Now, obviously, we are writing time. So time will get 1 power, the other two will get 0. And this is seconds. S also you can write, second also you can write. This way also, however you want to write. Even if you write simple S also, it's okay. Then is area. Area is, you know that, what is the formula? Length into breadth. When write in terms of words, you can write length into breadth. Now you see, okay. Now length into length. How much will the power become for the length? L into L is
square.
given. Yes,
L
L,
square.
F, yes. So now MLT we have to write. So from here we know that areas L is having power 2 and rest will be 0. So L into L means meter into meter, which is meter square. Because we are using standard one. We cannot write kilometer square because SI unit is meters. So here also we have to use meters. Length means meters. Meter into meter will give you meter square. Fifth one, volume. Volume will be length into breadth into height. So obviously it is length into all our lengths only. Means distance into distance into distance. So what will be the power?
L raised to Q.
Yes. So here put M will be 0, will be 3 meter cube you will. Till here, if anyone is not understood, please ask. Want me to repeat anything? You can ask. Huh? Then next one, sixth one. Volume. Oh, sorry, density. Density. Now this formula you should know either from your 10th standard. If you don't remember from 10th, now you should know. Density is mass upon volume. Density is equal to mass upon volume. So now you know what is the this for mass. From first one, refer your first line. That is M L T. What was there for mass? These were zeros and L was 1 from my first one, because mass means only, wait 1 second. This will be 1, yeah, mass. And volume was what? Refer second form, this length, mass and this I had done, no? And volume, just now here. Upon, no? So upon this. So mass I have put here, volume I put here. Anyone who has not understood the substitution? I have put the dimensional formula of mass in the numerator and I put the dimensional formula of volume in the denominator, which we have already done from the second and the fifth one. Now what to do with the powers? So in the basics of maths also I taught you, if you have x raised to something a and if you have x raised to b, it's always when you take this up, it will become a minus b. So whenever there's a positive here, if you take it to the numerator, it always changes its sign. If this was negative, this will become positive. So any letter you are taking up, the power becomes negative. So what we'll do now, 0 I'm taking up, here it anyways will not make so much difference. But while writing, now m I'm making common. So this will become 1 minus 0. Same way, now L. 0 is already there. Now this 3 I'm taking up. So plus 3 will become minus 3. T, anyway 0 minus 0. So what is my final answer? Calculate and then write. M1, L minus 3, T 0. In a college and all, sometimes if there's 0 and all, no, that letter they may skip also. Sometimes some of them they might write just like this only and keep. And it's understood that T is 0. Okay, T raised to this would be 0. But we'll follow this only so that there is no confusion. Anyone who has not understood from here how we got this, you can ask. Okay. Now we'll write a formula. Mass, what is the unit? Kg. Refer the table. Okay. Mass is written in terms of kg. Volume is written in terms of, yes, meter cube. So substitute the unit for this mass, substitute the unit for volume. Sometimes you can also take this also up and keep. Either this is also correct or kg. M you are taking up, then you can write it as minus 3. Both the way, both the ways are correct. Okay, I'll stop here for today. I'll continue with them. Around 27 of them are there like this. They are simple ones. Okay, you'll understand it. If anything you have not understood till now, you let me know. Just take attendance. Okay. Those who have finished can leave the meeting. Else, if you have any doubts related to today's class, you can wait and ask.